Hello students, welcome to YourPedia Education. My name is Arun Pathania and today we are going to solve an NPTEL assignment question for the subject of irrigation which has been taken from this particular book. So let us just start. So this is the question where we have a horizontal confined aquifer of 60 meter thick and the porosity and the compressibility of the 4 samples of the soils of aquifer are given below. So it's a sample A and sample B, C and D, and then compressibility of water is also given. We have to determine the representative value of storage coefficient and then we have to find the representative permeability of the aquifer soil if the average transmissibility coefficient is 18 into 10 raised to power minus 5 meters square per second. Okay, so this particular data has been given and we need to find what? We need to find storage coefficient and we need to find the permeability of this particular aquifer. तो सबसे पहले हम क्या करेंगे? हम लोगों को 4 वैल्यूज दी गई हैं of porosity and compressibility. Let us find the average value. So first what I did is कि मैंने average porosity निकाल लिया सभी को प्लस करके, then divided by 4. This will come out to be 0.35. Then the second thing that I calculated was the average compressibility. Now what is compressibility? Compressibility is the ease by which a material can be compressed easily. Okay, so जो compressibility है, that is basically the reciprocal of bulk modulus of a material. So when we do the reciprocal, we get the compressibility. So the compressibility of the soil, average compressibility, these 4 values are given. I took the average. This comes out to be 28.5 into 10 raised to power minus 6 centimeter square per kg. Okay, so this is average porosity, this is average compressibility. Now इस क्वेश्चन को करने से पहले I just want to tell you that what is the formula for the storage coefficient and what is the difference between confined aquifer and unconfined aquifer. So just look here. What is aquifer? Aquifer is a water bearing strata geological formation which has high permeability as well as high porosity. So that is aquifer. For example, gravel or sand, these all can be classified as aquifer. Now aquifer are of 2 types, unconfined aquifer and confined aquifer. Now what is the difference between both? In unconfined aquifer, these are not bound by an impervious stratum at the top. Okay, so for example, this sand is an aquifer which contains the groundwater. There is no impervious stratum above this particular layer. Okay, it is open at the top and such an aquifer will be called as unconfined aquifer. The top surface of the water in unconfined aquifer is called as the groundwater table. Okay, and if you make a well in an unconfined aquifer, then the water will only rise up to the level of the groundwater table only. It will not rise beyond that or okay. Next is your confined aquifer. Now what is confined aquifer? An aquifer which is bound by an impermeable stratum at the top also, at the bottom also. For example, here is an figure, as you can see. On the upside, on the top of this particular aquifer, there is clay layer, and you know clay layer is an example of aquiclude. It's an impervious stratum. It does not have high permeability, and at the top you have rocks which are both impervious as well as their porosity is also very low. So in that case, this becomes an confined aquifer, and the water present in the confined aquifer is under pressure. So whenever you dug a well in a confined aquifer, the water will rise up to the above the level of the top level of this confined aquifer and goes up to a level called as the piezometric surface, as you can see in this figure. So the top level up to which the water will rise, if a piezometer will be connected here or a well will be dug in the confined aquifer, is called as the piezometric surface. Piezometric surface is equivalent to the groundwater table in case of your confined aquifer. Okay, this occurs in unconfined aquifer, and piezometric surface is found in confined aquifer. So now next thing is your storage coefficient, also called as the storativity. So it is the volume of the water that can be drawn out of an aquifer of unit area when its piezometric surface or groundwater table falls by a unit distance, falls by 1 meter distance. Okay, so this is called as the storage coefficient. Storage coefficient itself is a dimensionless parameter. It does not have any dimension. The value of the storage coefficient is equal to the specific yield value for unconfined aquifers. What is specific yield? Specific yield is the ratio of the volume of the gravity water stored in aquifer. This is the amount of the water that can be, taken out of the aquifer easily. And the second, and in the denominator, we write the volume of the aquifer. So volume of the gravity water in the aquifer to the volume of the aquifer. This ratio is called as the specific yield. जितना ज़्यादा specific yield होगा, समझ लीजिए हमारा जो उतना ज़्यादा amount volume of water we can derive from this particular aquifer. Okay, next is your confined aquifer की case में specific storage coefficient का क्या formula हो जाएगा? This is the formula in case of your confined aquifer. Here this is the density of water. This is the thickness of the aquifer. So thickness is the thickness of the confined aquifer जो कि हम लोगों ने represent किया था. But this is the T, thickness of the aquifer. Then we have 1 upon ES. This is the compressibility of soil. हम लोगों ने पहले discuss किया था. Then N represents the porosity of the soil and KW represents the bulk modulus of water. And this 1 by KW is the compressibility of water. So हमारे को question में क्या दिया हुआ है? We have been given the compressibility of water. 1 by KW value is given here. Okay, this T value is also given there. Rho W value is 1000 kg per meter cube. This much we know. And N value and 1 upon ES value average we already found by from this particular table, which means we have all the parameters, and now we can easily calculate the storage coefficient for the confined aquifer given here. So what is the formula? Substituting all the values in this particular formula, I get my result as, all these values I substituted into this particular equation, and the result is 2.69 into 10 raised to power minus 4. It's a dimensionless parameter, so no units, and this will be the storage coefficient or storativity of this particular unconfined aquifer. So this is the answer of my part 1, where I have to find the storage coefficient. In second part, transmissibility has been given and we need to find the coefficient of permeability of this aquifer. Now first we should know what is transmissibility, only then we can find the K value. Now transmissibility represented by T is basically the discharge that is available from an aquifer of unit width under unit hydraulic gradient. So hydraulic gradient should also be unity and its width should also be unity. Then the amount of the discharge that we get from a particular aquifer is its transmissibility. So as we know the Darcy law that states that the discharge is equal to area of the cross section into the velocity, and the velocity will be what? The coefficient of permeability multiplied by the hydraulic gradient. In this case, your area can be written as width into thickness into K into I. So when your I will be equal to 1, equal to unity, and your width is equal to 1 meter, in that case Q becomes what? Q becomes T, transmissibility. So T will be equal to K into T, or we can say that K is equal to capital T upon small t, which is your transmissibility upon thickness. So just putting the results here, putting the values here, I get the value of K as 3 into 10 raised to power minus 6 meter per second. So this was the answer to this particular question. In the first part, we need to find the storage coefficient, and we know the formula to that. We just substituted all the values and we got the result. And second case mein we have to find the permeability, and for that formula is this one, and we substituted the values that has been given in the question and we got the results. Okay, so that's how you perform and as you solve this particular question. So that's it from my side. I wish you all the best for your future, and if you have any doubt regarding any question from the NPTEL assignments, you can write to us and we'll try to solve it as soon as possible. Thank you.